they are 3 to the power n minus 1 in number. Correct? This is 1 in number. Pairing will happen in this, and then separately this 1 has to be added. That's what has been done here. So that will give you the answer 3 to the power n plus 1 by 2. Is that okay? Understood now?
I've done a question like this.
Alright. We found the total number of ordered subsets which are disjoint. Total number of subsets, 2 subsets which are disjoint. Now, next operation that we are going to talk about. Now, this is the type of question that JEE can frame on sets.
So this is advanced.
This is base level.
What?
God save us. God save us.
As we do permutation combination, you will start realizing that these concepts everybody knows. Simple. You're learning it for the first time, that's why. Next operation that we are going to talk about, guys. No talking, please. No talking, please. Difference of 2 sets. You must be thinking, sir is making an easy topic also difficult somehow. Okay, difference of 2 sets represented as A minus B. As a set builder form, it is represented as a set containing all elements X such that X belongs to A and X does not belong to B. Okay. But the very wording of it, X belongs to A and X does not belong to B, doesn't give a feeling that this should also be A and not B. Right?
Yes.
So when you read this formula in your school, it is coming directly from the basic definition that it is all the elements which belong to set A, right? And you remove those elements that are also in set B from those set of elements in A. I'll give you an example. If I say, yes, I'll talk about B complement in some time. Let's say A is 1, 2, 3, 4. B is, let's say, 2, 4. Then what is A minus B?
1, 3,
1, 3. Are you getting it? So all the elements which belong to A but not to B will be listed under A minus B, also written as A intersection B complement. Okay. Now this is something which you can also realize on the Venn diagram. A minus B is this zone. Boys and girls, please note this. Okay. A minus B is this zone. Similarly, what is B minus A? All elements which belong to B and do not belong to A. Okay. For example, in this case, if I ask you what is B minus A, what will you say? Null set, because all the elements here belong to this. But let's say if I had 5 and 6, then you say 5 and 6. Sure. So this is A minus B, whereas this is B minus A. Right? You can also write B minus A as B intersection A complement. Is that okay? If you look at the diagram very carefully, you can also say A minus B is right. A minus B is basically what? A union B minus so,
or it could also just be
yes,
A minus A intersection B.
yes. Is that okay? Is the difference of 2 sets clear to you? Can I erase this?
Yes, sir.
difference of two sets. This may not have been dealt with in school.
We did it. So we did it.
You did it.
When did you do it? I didn't know.
Symmetric difference of two sets is written as A delta B. Some books will also represent it as this. No?
Hey, we did.
No?
No, you've not done it.
Not done it. We didn't do it.
Yeah.
Now,
Discussing.
showing you in a Venn diagram, symmetric difference of two sets is basically the union of A minus B and B minus A.
What? Isn't that always a null set? Don't you think?
If I take the union of A minus B and B minus A, it would be a null set if I take their intersection, not their union. Okay? So,
Section B. Yeah.
right. It is also written as A union B minus A intersection B, which will be proving mathematically also in some time.
So Venn diagram is.
But with the use of laws and properties, we will be proving it. Okay. Is it understood symmetric difference between A and B? Last but not the least, complement of a set. Complement of a set A written as A with a superscript of C. Some books will write it as A dash, some books will write it as A bar. What does it mean? It means a set containing all elements X such that X belongs to the universal set and does not belong to A.
So U minus A.
Right. So it is basically going to be the area outside the set A. This is called the A complement zone. Is that okay? So for understanding A complement, the concept of universal set should be clear in your mind. Is that okay? Moving on, laws of sets or algebra of sets. This A bar. What about Nika? Head is 18. The fun part is functions part. Sets to a certain extent and relation to a certain extent
Transformation of graphs is part of
Sir, the proofs are nice.
Transformation of graphs is part of functions.
But I'm not going to teach it. I already taught them transformation of graphs in bridge course. Full 1 month I taught.
What do you mean by the bridge course?
Bridge course is transition from 10th to 11th. I made a bridge for them. Literally. Yes or no? Prithvi will agree with me. Okay, here is this. Ashutosh, any questions? Next we are going to talk about laws of sets. Very, very important. You may get questions on laws of sets. However, these are some laws which are very fundamental. And to prove them, you have to mostly rely on logic. Okay? Logical statements. I'll start with the first law, which is called the idempotent law. The word idempotent means applied to itself. Okay. Under this law, we are going to study two very trivial laws. A union A is A, and A intersection is also A.
Okay.
Sir, how do you go about proving such a thing?
That's all. It's very fundamental.
Sir, yeah.
You can say that.
What is the need for stating these?
If I give you a proof for this, you'll probably think it's so trivial. I mean, how can somebody give a proof for that? Okay. If I say X, let X belong to A union A. Correct? This implies and is implied by X belongs to A or X belongs to A. why it will cover both the things.
So I asked my
We are
teacher,
not
she
so
said,
fortunate.
Take your call. I mean, it's school teacher.
Sir, we are not so fortunate.
If I were your school teacher, I would have allowed this. Okay. That's a very trivial proof. So, for the proof of these laws of sets, we are going to just follow these elementary proofs or arbitrary element proofs.
next up.
Okay. I'm not going to waste your time and my time by doing the B part. I'm going to move to identity law.
Sir, this is all. Okay, fine.
Identity law says a union with universal set is going to be the universal set. A intersection with the universal set is going to be A. A union with the null set is going to be A, whereas A intersection with the null set is going to be a null set. So these four laws are collectively called the identity laws. They are very trivial proofs.
Sir,
A plus nothingness is
I tell you what will come.
A intersection.
sir, why do we even need the idempotent now, sir?
Why even
If you are posed with a situation where you are taking the union of a set with itself, you should know what it is.
idempotent?
Idempotent law. The name is more complicated.
Exactly.
Idempotent is something which you'll hear again in the matrices chart next year. Not this one. Can I move on? You know, these chapters are even missing from your JEE Advanced books. They never talk about sets.
Yeah.
Yeah, no one talks about it. Yeah.
Sir, I have all volumes.
As I told you, it comes with probability and all.
Not right now.
Not with the sun.
They haven't written sets in that one. It's not a
Can I move on, guys and girls? Anika?
on all of the career point material, they haven't mentioned sets.
Fireworks happening? What up?
Oh,
Alright guys, please pay attention here.
Not even once the
Next week we will talk about commutative law. Commutative law, under this law we are going to study two things. A union B is same as B union A. And A intersection B is same as B intersection A. Okay. Again, proof for this is very trivial. When you say an element X belongs to A union B means X belongs to A or X belongs to B. You can switch it and say X belongs to B or X belongs to A, and hence X belongs to B union A. So A union B is a subset of B union A, and you can do the reverse step to prove that B union A is also a subset of A union B. So I'm not going to do all those things. It's very evident. In a similar way, you can say A intersection B. Next is associative law. Associative law says if you are performing the union of two sets and then again perform a union with some other set C, it has the same impact as this. Okay? In a similar way, if you are performing the intersection of the sets like this, it will have the same impact as this. So the association can change pairs, but the final result would be the same. So A union B, first found, then union C is same as A union of B union C. Next is Next is distributive law. First I will talk about, please come in, distribution of union over intersection. So A union B intersection C is A union B intersection A union C. Okay. We can have distribution of intersection also over union written as A intersection B union C is A intersection B union A intersection C. One of the very widely used laws in sets is this distributive law. Again, the proof for this is, should I prove one of them by using elementary now?
Sir, or we could ask us to do it now, sir, as a challenge.
It's not a challenge, it's very, the steps are very, very trivial. Very trivial. Neha, should I do a proof for this? No. Okay. The last law is the Morgan's law.
What?
So Morgan, Mr. Morgan gave a law. Shortcut Morgan. Okay. I'm kidding. Okay. I'm just joking. In De Morgan's law, we have to study the two original laws of De Morgan, which was A union B complement is A complement intersection B complement, and A intersection B complement is A complement union B complement. And there are two derived laws from it, which is A minus B union C is A minus B intersection A minus C, and A minus B intersection C is A minus B union A minus C.
So never negative.
Now guys and girls, I would like you to spend some time proving C and D
Oh, that's it.
by using laws.
Not for us, for you.
Please try proving it by using the laws which we discussed before this. C and D. That I don't know which law it is.
Yeah, I don't want to do like this.
Yeah, can you use method?
Huh?
Can you use method?
So easy.
No one diagram this. Grow up. Not Venn diagram.
I don't know. I don't like this. No, but it gets complex with 4.
It may come as a problem, potential problem for you in your school test.
Yeah, I know. That's why it's
Sir, done.
Come.
yeah, obviously.
So you can just expand A.
Expand A intersection B.
I was studying the basic problems in that. Sir.
What? Expand A minus B union C as A
Is it done?
intersection B union C complement.
Yeah, that's basically all I have.
Whoosh.
Good idea, sir.
Are you done with any one of them? B or C or D? Wait. Sorry. Shashank. Shashank. Your name I will never get. Shashank.
And Sushant.
Shashank. 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 Shashank.
Yeah, that's a good idea.
Samir. If I do C1, you'll be able to do D1 also,
Sir,
right?
actually for C we can use item coded to name.
No, not good. Okay, start from LHS.
Oh, okay.
Guys, sometimes some problems are very much specific to which side you start. Right? Let me start with the left hand side. Do you recall when I talked about A minus B? I also defined it as A intersection B complement, isn't it? So can I write this as A intersection complement of B union C? Correct? Can I say by De Morgan's law that this can be written as B complement intersection C complement?
Yeah.
Yes or no? Now I can also follow distributive of intersection over intersection like this. A intersection B complement intersection A intersection C complement.
Or sir, in order to better justify that, we could basically just say A is equal to A intersection A.
Right.
Just use associative.
Right. A intersection A is A intersection A as we told idempotent law.
Okay.
So you can write this as A intersection B complement is A minus B. Intersection A intersection C is A minus C, which is your RHS.
Or you can just use RHS as
Please come.
Genius.
Correct? This is through the use of the laws which we just now studied. However, in school, if you want to do it by arbitrary element method, that is also I am going to show you now. Just one I will show you. After that, I will not show you.
So you take set A as 1, 2, 3, 4, 5, 6.
No.
That is verification.
You can't take
Examples.
X belong to A minus B union C.
You have to take an arbitrary element proof. You cannot take examples to prove a law.
Therefore, X answer.
You can verify a law with an example. You cannot prove a law with an example.
So we can basically say let X belong to A minus B union.
Alright, I am going to do that.
Then X belongs to A, but X does not belong to B.
Clear, Khati?
And X does not belong to C.
Laksha, clear?
X does not belong to A, X does not belong to C. You know that.
Away. Clear? I am going to ask you a lot of questions like this. Next 45 minutes I am going to ask you questions like this only. Can I erase this? An alternative proof for this that we normally follow in school tests will say let X be an element belonging to A minus B union C, which implies and is implied by. If I write these two symbols, I don't know what is accepted in school, then I don't have to prove one is a subset of another, another is a subset of another separately. You can prove in one go on. Okay. Which implies X is an element of A and X is not an element of B union C.
Therefore, X does not belong to B, X does not belong to C.
Which implies X belongs to A and X does not belong to B and X does not belong to C.
Oh. Oh, so for hand you put intersection. Oh.
Very important. This is the step which is going to make the difference.
And operative.
If something does not belong to B union C, it should not belong to B also and C also.
It belongs to B union C complement.
It belongs to B complement, it belongs to C complement, therefore we will intersection.
Is that okay? Now this means X should not belong to A and X should not belong to B. And X should not belong to A and X should not belong to C. Yes or no?
That's all well done.
Which means X belongs to
A minus
A minus
B.
B and X belongs to A minus C. Which means X belongs to A minus B intersection A minus C. Which implies A minus B union C is a subset of A minus B intersection A minus C, and A minus B intersection A minus C is also a subset of A minus B union C. I wrote this double direction arrows just to save time.
Otherwise,
You have to write the same set of steps in a reverse order.
Exactly.
Now it's your call whether you want to waste time like that or you can do it in reverse. Okay, but just take a permission from your school teacher also.
So there's no need to read
Hey,
it.
what is a waterman?
Someone, wait.
Hey, save it.
Hey, someone. Hey, I'm going to give you a break. Hold on. Can I also go? Can we take problems?
Yes, sir. Sir,
what's up?
Give it up.
Give him one bucket only, no?
Sir, we've done enough buckets last week in physics. Okay, fine.
Okay, don't do the one which is just do it.
Prove the following by using the laws of sense.
Yes, sir.
You'll find the fourth problem familiar to you.
Sir, as in like we are expected to have solved it already, or we'll see it a lot.
You'll see a lot. Only by using the laws of sense. You know Venn diagram, no elementary element proof.
There